Hi, and welcome back to Red Siege's Shellcode Obfuscation series. In this episode, we're going to take a look at Jigsaw. Jigsaw is a shellcode encoding technique that I came up with that is essentially a substitution cipher coupled with some randomness. The idea is that when you look at a jigsaw puzzle, you open it up, you dump all the pieces out on the table. There's no rhyme or reason to the pieces. Without the picture on the front of the box, you're going to have a really hard time getting the puzzle back together. And that is the idea with Jigsaw. So let's take a look at the code so we can see exactly how this works and see if it's very effective. All right. So we've got a Python script that will generate our Jigsaw code for us. So it's pretty simple. It takes a bin formatted shellcode file as input and outputs a file called jigsaw.txt. And it runs this generate jigsaw. So generate jigsaw will read in our raw shellcode, figure out how long that shellcode is. And then it's going to create a list called raw positions. And that list is going to contain as many entries as our shellcode has bytes. So we do that by populating the list using the range function, using a range of 0 to the length of our shellcode. And then we call random.shuffle. And what that does is it takes our list, which was previously, for instance, 0, 1, 2, 3, 4, 5, and it shuffles that to be some new random order. So it might be 3, 2, 4, 5, 1, 0, or it might be 2, 4, 3, 5, 1, 0. Any combination that it can come up with, it's going to generate a random order of that list. Now, what we do is we have our raw positions, which is our shuffled list of positions, and there are as many positions in that list as there are bytes in our shellcode. We're going to iterate through our list of positions. So let's say, for instance, the first position in our list was 10. We are going to then look up in our array of shellcode at the 10th position, grab that value, and append it to a new list called Jigsaw. And we're going to iterate through each of the positions in that random list. And we're going to grab the byte that corresponds to that value uh, of that index in the shellcode array. So let's take a look at what the output looks like. So here is the output from Jigsaw. So we have Jigsaw, which is our scrambled shellcode. So we see here, these are our shellcode bytes. We do not see FC48, so on and so forth. It doesn't end with FFD5. And the reason that is because this is our shuffled list of positions. So the first entry is 305. So if the first entry is 305, then this is going to be the shellcode byte that's at the 305th position of our original shellcode array. To reconstruct our shellcode, all we need to do is iterate through positions, the positions array, that's this. We take a look at that value, which if we're at index 0, that means we grab 305 from here. And the position variable will be equal to positions at the index. So position right now is going to be 305 because we're at index 0. We're now going to reconstruct our shellcode, and we're going to insert our position. So, or rather at that position. So Remember, position was 305. So at calc payload index 305, we're going to grab the value of Jigsaw at our current index, which is 53, because we're at index 0. So that means we are going to insert at calc payload 305 the value that's at Jigsaw 0, which is 53. So now the 305th position in our shellcode array, which is called calc payload in this instance, contains 0x53. So let's take a look at that on our Windows system. So this is what the source code looks like. We've got our jigsaw of scrambled shellcode, our positions array of scrambled or randomized positions, and we're going to print out the output. And you can see here we've got a printf because Defender's already detecting this technique. Good for them. So when we run it, FC4883E4 ends with FFD5, exactly like we thought it would. We check it with Defender, no problems. And if we check that with Virus Total, let's see how that fared. Remember, Jargon got 4, I believe. Well, Jigsaw got 4 as well. So it's a pretty comparable technique. So this is something you could use to obfuscate your shellcode, to not have to use encryption and greatly increase the entropy, although there's these randomized numbers and randomized positions. So the entropy is definitely higher than unencrypted shellcode. However, this is a fairly effective technique for hiding your shellcode. So with that, that is the end of this installment. Thank you for checking it out. If you want to use Jigsaw, you can go to github.com/redsiege/jigsaw. You can grab the code. Feel free to test it out. And if you find any problems, be sure to send a pull request. Stay tuned for the next episode. Thanks.